Okay, this video today is going to be about scientific notation. In science and in the world, we often have things that use really big numbers. For example, if we talk about distances to planets or something that happened a really long time ago. Okay, in those situations, we have really big numbers that have a lot of zeros in them. Now, I've said in the past that people who do maths, they like to be a little bit lazy. Okay, this is not necessarily a lazy thing so much as a way of making things easier, but this is basically a shorter way of writing really big numbers. Okay, so we have, for example, a number like 23000, something like this. Okay, you can see there's a lot of zeros there. And we want to find a shorter way of writing it than having to write out all these zeros all the time. So what we use is therefore scientific notation. For scientific notation, you have to think about firstly, where is the decimal point in our number? So in the beginning, our decimal point is over here on the end. Okay, you know that after that point there's a lot more zeros, but for now, that's where our decimal point is sitting. What we're going to do is we're going to move this decimal point, and we always move it so that it is after the first non-zero number. Okay, so the first non-zero number here is 2, and we're going to put our decimal point next to that 2. Okay, so it's now after the 2. What we then need to do, so we have 2.3 here, so we know that we're going to start with 2.3, okay, that you get from the start of this number here. Then what we do is we look at how far we moved that decimal point. So what you can do is you can just count the jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so when we do scientific notation, it's always times 10 to the power of how many jumps we made. So we made 10 jumps here, so it's times 10 to the power of 10. How does that work? Why is this something that we can do? Okay, if you had, for example, let's start with a number that you know, 340. Okay, something nice and small. We wouldn't normally bother writing this in scientific notation, but we can. This is the same as, so if you look at it, we currently have a decimal point here. We're going to move it to after the first non-zero digit, which is here, and it moves by 2 spaces. Okay, so we have 3.4 times 10 to the power of 2. Okay, what is 10 to the power of 2? You guys have learned that before. 10 to the power of 2 is equal to 100. So if you take 3.4 and you times it by 10 to the power of 2, that's the same as 3.4 times 100. And you know that when we times by 100, we move the decimal point 2 spaces. So we end up with 340. Okay, so this is how scientific notation works with very big numbers. So if we have a really big number, we can write it in scientific notation now. As I said, the decimal point must go after the first digit. All right, so for example, if we had 6, 5, 3, 8, 2, 0, 0, 0, 0, 0, whatever. Okay, and now we want to look at what we're going to do. So again, our decimal point starts at the end. That's where it is right now. And we want it after the first non-zero digit. Now that doesn't mean between the 8 and the 2. What that means is we're going to put it over here between the 6 and the 5. Okay, so we know our new number is going to be 6.5382. Okay, we're keeping all the data that we know, and we've moved it by 1, 2, 3, 4, 5, 6, 7, 8, 9 jumps. So it's going to be times 10 to the power of 9. Okay, so that is how we write numbers in scientific notation. Sometimes you're going to get this in a different way. So you might receive a number that's in scientific notation and you need to write this in normal notation, in standard notation. So we're going to do that as well. So let's say that you've got the number 9.53 times 10 to the power of 5, and you need to write that in standard notation. So what I always do is I start with my 9.53. Okay, now we know it's times 10 to the power of 5, so we're just doing the opposite of what we did when we wrote the numbers in scientific notation, and that means in here we counted how many jumps it made. What we're doing now is we're actually going to make the jumps. So our decimal point has to move by 5 places. That's that 5 that's here above the 10. Okay, so we're going to make that jump. So we're getting 5 spots. 1, 2, 3, 4, 5. And this is now where our decimal point is going to go. Now, of course, we've now got these gaps here. So what you need to do is you need to fill in the gaps with zeros to show that under each jump, there's now a 0. So we put those in. And that means what we actually have is, we don't need this decimal at the beginning anymore, so we have 9, don't know what's going wrong today, 953,000. So we have 953,000. Okay, this is as difficult as it's getting for now, for the big numbers. Okay, let's do another one. 2.1 times 10 to the power of 8. Okay, so we start with 2.1. We have to move our decimal 8 spots. So we're going to make 8 jumps. 1, 2, 3, 4, 5, 6, 7, 8. Our decimal is now here. Okay, and we fill in the gaps with zeros. So we've added 7 zeros in this case, which gives us 2. Remember that decimal we don't need to write anymore. 1, 0, 0, 0, 0, 0, 0, 0. Let's check that that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. 1, 2, 3. Yes, we've got 9 digits in total in both of them. Okay, so this is how we write numbers in scientific notation if they are large, and how we write scientific notation numbers back in standard form.